So, good morning, folks. I am Manoj Kumar Gali, an associate consultant at AST Corporation. Today, I'm going to present you all with the introduction to Amazon Web Services, Redshift, and Tableau. So, let's get into it. So, our agenda is first, why do we need a data warehouse, and why do we need to select Amazon Web Services Redshift as a data warehouse, and what are the benefits of Redshift, and what is the comparison of Redshift to other existing data warehouses, and what is the architecture of the Redshift, and how the data is being distributed among the Redshift, and what are the distribution types in Redshift, and how the data is being loaded into the Redshift. And additionally, there will be a sample report making in Tableau, and I'll be showing you everything both theoretically and practically in the live demo. So let's get into it. Why do we need a data warehouse? So let's consider an OLTP system in which on the left side there are some normal users, day-to-day users, making them transactions like querying the data and loading the data and getting the data. There will be a small transactions going on them, and there will be a right side some business users. They will be running the huge queries to pull the data from the database and make some analysis or reports out of it. So in this scenario, when both users are doing it simultaneously, the load will be the load on the database will be very high, and they cannot make the fast reads and writes because there are huge queries going on at the same time. So to avoid this, we built a data warehouse in which we extract, transform, and load the useful data from the OLTP system and load the data into the OLTP system, which is a data warehouse, so that users can interact with the OLTP system itself, and there is no interaction between the OLTP system and the business analysts. So analysts they can run their huge queries to get the analytical data from the data warehouse and do the reports out of it. So now the one problem is solved, and the next one is when the data is getting bigger and bigger, the maintenance cost will go up, and there will be we have to get the extra hardware and extra maintenance and extra persons to handle the work. So what's the next step is keeping the data warehouse into the cloud. So in this session, the mostly interested topic is why Redshift and what is Redshift. So first of all, I want to introduce the Amazon Web Services. So the Amazon Web Services, they provide different services like compute. So they provide the servers for our users, they provide storage, they provide database services, they provide application services, and they provide deployments and administration. So with Amazon Web Services, we can do the whole DevOps work, like from the development to the operations, like developing the application and deploying the application. So we are mostly interested in the database for this session. So what are the databases that Amazon provides us? So first one is the Redshift. Redshift is the cloud data warehouse that Amazon provides us. It's a columnar database. Let me talk about that later. And the next one is the Amazon DynamoDB. So this is a special database that is built by the Amazon Web Services, which is a NoSQL database. And the next one is the Amazon RDS, which is a fairly relational database, so we can install either Oracle, MySQL, Microsoft Server, everything like that into the Amazon RDS. So the next one is Amazon Elastic Cache. So this is another AWS service in which we can cache all our temporary memory in the cloud, and we can connect to that temporary memory and use that temporary memory to maybe to our cloud compute servers or to our on-premise compute servers. So let us go into the Amazon Redshift in detail. So the Amazon Redshift, it is a relational data warehouse, so we will be having the relational compatibility with it, and it is massively parallel. So this massively parallel means it can be extended in not in the horizontal way. Not in the serial way. It can be extended in the parallel way. So if we want more and more, we have to add another redshift, another cluster, so we can increase it parallelly indefinitely. So what is the scale we increase means? It's a petabyte scale. So we can build an Amazon Redshift in a petabyte scale. If you want 10 petabytes, if you want 2, it's based upon that. So it provides 2 platforms, which is a hard disk and a solid state disk platform. So based on our requirements, we can choose either hard disk or a solid state disk. And also coming into the benefits of the Redshift, the cost is very low, so we don't pay any upright costs to the Amazon Redshift. We only pay as we go. Like if we want only 1 cluster or 1 node, we pay only for 1 node. If you want 2, then the costs go up. If you resize them into the 1, then the cost will come down. So there will not be any licensing costs or pay upright costs. So it is easy to use in that any cluster we can provision it in like within a minute. So we can provision a cluster like within 4 clicks maybe, and if we can also resize the cluster with only 2 clicks. We just have to click the resize button and we have to tell it how many nodes we need. And the backups, coming to the backup section, it automatically takes incremental backups. So if it only takes backup, it doesn't take backup every day. So it takes whenever there is some change in the data. So if there is any change in the data, it automatically recognizes it and backs it up like in everyday fashion. And and also the another benefit we are getting from the Redshift is monitoring the query for performance. So there will be a monitoring tab in the Redshift which will be used to monitor how many queries are running and what's the time of the query it is taking, like that. And another thing about the Redshift is it is a columnar storage. So for any query you're running, it doesn't take the whole row, it only takes the whatever the column we are searching for. So in terms of input and output speeds, this will be very high. So if you are querying any column, any data, so it only picks up whatever the column it is. So it doesn't have look for the whole row and give the whole row as an output. So coming into the integrations, so the Redshift, it doesn't have it's basically a data warehouse. So it doesn't have any security, it doesn't have any logging, it doesn't have any monitoring integrated within the Redshift. But we have another AWS services like AWS VPC, which provides us with the security, and AWS CloudWatch, which provides us with the monitoring capabilities, and AWS Logstash, which will be used for logging the sessions and everything. So the one good thing about this is we don't need to integrate these services. It's all integrated internally. So whenever we want to change our security, we just have to go into the AWS VPC service and we just change there, and it will automatically be populated in our Redshift. So if we want to create an alarm with a monitoring alarm, so we just have to go to CloudWatch and create an alarm there based on the Redshift metric, and it will populate automatically the alarm or in the dashboard of the CloudWatch. And coming to the compatibility, so as it is a cloud service, it is compatible to everybody, in the sense every browser we have. So we can use any browser that is existing right now to open up the AWS services. So when comparing to our Redshift to our existing RDBMS data warehouses like Oracle, MySQL, and MS servers, these are some pros and cons. So these pros and cons are in the perspective of our RDBMS data warehouses. So some of the cons about the RDBMS data warehouses are they are row-based lookups. So when we are querying some data, so it gives us the whole row. So in terms of input and output speeds, it will be slow, and it is self-maintained. So there should be somebody sitting on the RDBMS data warehouses to administer it and to maintain it. And there are some licensing costs when we are trying to acquire it. So these are some cons. And when comparing to our Redshift RDBMS data warehouses, they are faster and we have full control. When we are gathering some database, we are getting the whole compute power with it. So we can log into our compute server as a root and do some customizations if we want, and do some cron jobs on backing it up. Everything will be customized, but we don't have the customizations in the Redshift. And it is, of course, it is a OLTP system, so it will be very fast. And also we have our own analytical dashboards to build our analytics, but Redshift doesn't have anything like that. So they have to integrate with other third-party tools, and they have to ETL it and to get the analytical dashboards out of it. So let us go into the high-level architecture of the Redshift. So this is the picture of high-level architecture of the Redshift. So the whole thing is called the cluster. So the top one is called the leader node, and the below three of them are called compute nodes. So here there are 4 nodes. So the first one is the leader node, and the top remaining 3 are the compute nodes. For example, we build a cluster with 32 nodes. Then the first one will be the leader node, and the remaining 31 will be the compute nodes. So what is the responsibilities of the compute node and the leader node? So the compute nodes are responsible for containing the data and storing the data. Sorry, loading the data and storing the data. But the leader node is responsible for connecting to a BI client like Tableau or our BIX or data visualizer, and leader node is also responsible for connecting to the compute nodes and pulling up whatever the data is requested from the BI client. So till now we have seen the architecture, and coming into the data distribution. So how the data is distributed in the compute nodes when we are injecting some data into it. So let us take a cluster, for example, and in this, the first one is the leader node. So we don't want the leader node in the data distribution scenario. So we just take a single node, a single compute node. So there are some naming standards in the Amazon. So we have to choose how based on our requirement, which is desired for us. So for a DS2 Excel, that is the name of the cluster. It will have 4 CPUs in each compute nodes, which I am showing you as in the figure, the S1, S2, and S3, and S4. Those are the 4 slices. So number of CPUs is equal to number of slices. So for DS2 Excel, which will have 4 CPUs, will have 4 slices. So the maximum number of CPUs we can get in a single compute node is 32. So DS2 8 Excel, which will have 32 CPUs, that means we have 32 slices. Like in each compute node, there will be S1 to S32. That means 32 slices. The data distribution will be done based on these slices, and how the data distribution is done comes into this slide, which is data distribution types. So the data distribution types from the AWS documentation, what they say is this data distribution strategy which we choose is very important, because it will affect our query performance, and it will affect the storage requirements, and it will also affect the data loading and data maintenance, because After we discuss what are the types, you will get to know how they're affecting it. So there are three types of data distributions. There's the even, key, and all. Coming to the even, so in the even, the data will be loaded into the compute node in a simple round-robin distribution fashion. So, and also it is the default distribution type. If you are not telling the Redshift, so this is my default distribution type, it takes even by default. So how the even distribution is done is, if for example, if you have 1200 records that we are loading into the compute node, what it will do is it will evenly distribute into the slices. For example, if you have 1200 records, if we want to distribute among the 4 slices, it will divide it into the 300 records as a part. So in the S1, it will inject 300 records, and then next 300 records will go to S2, and next 300 will go to S3, and next 300 will go to S4. So in this fashion, the data will be loaded as a round-robin technique. So coming to the key distribution type, for example, let's take two tables which have a date width and another table with which is a date dimension which is equal to row width. So in this table, the date width is equal to row width in this table. So we have a matching value. So what AWS Redshift will do is, at the time of loading, it will automatically recognize the matching values based on the foreign key constraints which is set at the time of ETL, and it will place these matching values in a single node, so that when we are querying the data, it doesn't have to join two compute nodes to get the data out of it. So it just gives the data from the single node. So entire the concept is based on the speed, so it will make the speed happen. Next, coming to the all, if the same thing, by the name itself we can understand, it will distribute the data among the compute nodes entirely in each node. So for example, if we have the same 1200 records and we are injecting the 1200 records into the 3 compute nodes which I'm showing here, so what it will do is it will push all the 1200 records into each compute node. So it will have 1200 here, it will have 1200 here, it will have 1200 here. It's simply duplicating the whatever the data we're giving, and it is putting the data in everywhere in the each compute node. So the main disadvantage is with this all key distribution type, it will be very slow, and it is rarely used in the real world scenarios. So based on this types, we can answer the questions like why the query performance is affecting. So based on our requirements, we can choose whatever the distribution type we need, and based on the distribution type, the performance of the Redshift will be depending. So how the data is loaded into Redshift? The first thing we can think of as ETL. So we may primarily have a database which is holding all our transactions. So we extract that and transform it, whatever the transformations we need, and load the data into the Redshift using a third-party ETL tool. And the second way to do it is using a flat files. So we can either use CSV files or Excel files to load the data into the Redshift. And the Redshift is a PostgreSQL, runs on a PostgreSQL, so we can build a PostgreSQL insert scripts or create table statements, and we can run them in our SQL client to insert the data into the Redshift. So these are all the traditional ways to do it, and the other way is the special way which is introduced by the Amazon, which is getting the data into the storage unit of the Amazon services, which is the Amazon S3, this is a storage unit that is provided by the Amazon. So we can upload all our data into the S3, and we can upload that data into the Redshift. So by listening to that, we'll get a question like, why do we want to upload the data into the S3 and then re-upload into the Redshift? So the same thing happened in our AST. We had a problem like loading the huge files into our database as a service cloud. So what we did is we opened up the compute server, and we WinSCP'd the huge SQL scripts into the server, and using the SQL plus command line, we inserted the huge data sets into our DBAS. So the same thing can be done in the Amazon too. So as it is a data warehouse, and also we will be loading the huge amounts of data, we cannot do in a flat files or PostgreSQL scripts. We cannot do that. Like ideally, we cannot do that. So what should we do is we integrate another AWS service, which is S3. So what is S3? It's a simple storage service. It's a safe and secure object storage. So it will give us a simple web portal. So with an upload button, we can upload a single upload can be like a file can be a 5 TB size. So we can upload 5 terabytes of data file at a time into the S3. So we are getting the data into the S3. That means we already have the data in the Amazon Web Services. So we just have to get the data from the S3 bucket into the Redshift. So to do that, Amazon gave a special command, and an easy way to do it is using a copy command, which I'll show you in the later demo. So for now, the Amazon part is over, and the next, the Tableau. So Tableau is a rapid BI tool which will be used to create some great visualizations based on our data. So we can create analysis and group up those analysis and create a dashboard, and group up those dashboards and create a nice story to present it to users. So it is very easy to use and very fast in terms of creating the visualizations. So the three simple stages in Tableau is we import the data, like we connect the data source into the Tableau, and we create the analysis and dashboards based on the data, and we publish the results. So up to now we have seen the theoretical parts of what is Amazon, right? What is Amazon Web Services, and what are the web services we are using, and what is Redshift, and how the data distribution types, and how the data is loading into Redshift, and what is an S3 and how to use the S3 bucket, and what is Tableau and how to create and what the Tableau is used for. So based on this theoretical knowledge, I'm going to give a demo based on this. So first we have to go to a browser. First we have to go into the browser, and go to Amazon Web Services console. So going into aws.amazon.com/console, which it will give us this window. So here we have to sign into the console to see what are the web services that Amazon offer. So we just have to sign in. Yep. So as I already signed in, it doesn't ask me the credentials to sign in. So if you click the sign in button, it will ask you the username and password for the account, and just give the username and password, and this window will show up. So these are all the AWS services listed below. So the first thing we have to do is we can either look up manually or we can search. So for this demo, the agenda would be creating a Redshift cluster, connecting the Redshift cluster to the SQL client installed in our laptop, and using that loading the data into the Redshift and connecting the Redshift to the Tableau and making a sample report of the Tableau. So first we have to launch a cluster. So going to the Redshift, we have to search a Redshift there, and this will pop up, and clicking on this link will show up. So as you can see, there are some options in the left side: the cluster, snapshot, security, parameters, reserve, connect client. So this is the Redshift dashboard I'm in. So the clusters tab will show us what are the clusters we created and what is and details about the clusters and the snapshots. So this snapshots is we can create the storage snapshot of whatever the storage in our AWS Redshift cluster is, and we can store the snapshots in the cloud. So the security tab will show us what are the security constraints that is being used to create this Redshift. I'll show you how to create a security and use that security to create to get into the Redshift. So let's go into the launch cluster button. So we want to launch a cluster. So click on the launch cluster, and with this will come up. We have to give what are the details to launch a cluster. The cluster identifier is unique, so we can't give a duplicate one which is already being used. So we have to give like this. So there is no underscores being used like in Oracle, so we have to use dashes here. So you have to give the database name, which is anything, and this is the default port for the database port. We can change it or we can use it. We have to give the username, master username and password, and just hit the continue. So if we continue, then the next step would be node configuration. So as I told you, there will be different options to choose the nodes from. So I'll be choosing this GSC1 large because this is the free one we are getting from the Amazon. So the free service will be for 2 months. So it cannot be used indefinitely. So we'll be having a free hours of 750 hours per month. So for the first month you'll have 750, and the second month you'll have 750. So we can choose whatever the node it is, and from the DC1 large it will give us how many compute servers we are getting per node. So we are getting 7 EC2 compute nodes. EC2 means it is a EC2 is also another service by the Amazon which will give the compute servers. So it will be for the DC1 large, it will be giving 7 EC2 compute units, which will be having 2 cores per node, and also we'll be getting 15 gigabytes of RAM and 160 gigabytes of solid state storage per node. And we can choose either it is a single node or a multi-node. So from my presentation earlier, I've been showing a 4-node cluster. So if we choose a multi-node, and if we choose number of nodes equal to 4, then we will be getting a 4-node cluster in which the first one will be the leader node and the remaining 3 are the compute nodes. The maximum we can choose are 32 nodes. So in this case we'll be getting the first one as a leader node and the remaining 31 are the compute nodes. So we can choose whatever we want, how many nodes we want. So for if we want to try the Redshift for a demo purpose, we can choose the single node because we have the restriction like we can use only 750 hours of free usage. So we can choose only single node and just hit continue, and it will show. So this is the parameter group. So these are all given by default. So coming into the single each details in detail, this is the parameter group. So this is where we can set up the parameters, a parameter group, and we can choose what are the parameters we have. So it will ask to whether it is to encrypt the database or not. We can choose yes, or we can choose what are the database encryption type you want. And the next one would be the VPC, which is another AWS service. I'll show you. So in this, we can choose the VPC, and it will come up. In the VPC, which the VPC means is a virtual private cloud. So what I told you earlier in my presentation, we don't need to integrate anything. So we just have to create a new VPC, and it can be used anywhere in the AWS services. So I created a new VPC, which is a default one. So with this VPC, what we can do is, what is done is, it will create a virtually private space in the cloud, and our Redshift will be going into that virtual private space, and it is going to install in that virtual private cloud. So in this, we can choose what are the subnets we need to get the network open, and what are the internet gateways, and it basically like it is giving the security for our Redshift in terms of who can connect and who can access the Redshift. So we can create a new VPC here and use that VPC in this drop-down box. So I have only one, so it will be populated like that. So everything is default, and this is the security group. In the security group, this is also the new thing. Amazon, it's actually always integrated with the server parameters, but in the Amazon, it is got out of the server parameters, and they made a new security group. So in that security group, we can implement like we can choose what are the TCP IPs that are allowed to connect to the server, and what is the HTTP port opening, and what is the TCP port opening. So we can choose, we can change what are the ports, and we can open and close the ports of the server. So the next thing is CloudWatch alarm. So this one is also another AWS service. So CloudWatch. So this CloudWatch. It tells us it's basically an alarm dashboard. It will gives us. It will be monitoring our Redshift. In this case, it is Redshift, or it can monitor everything like our servers and everything. So by monitoring it, and it will give us some alarms showing like I created an alarm which will give me like if my bill is going over $5, it will send me an email like your billing is going over $5, you're charged. So by that we can do that, or we can create a new alarm based on our whatever the metrics we have. So in my AWS console, I have only Redshift and an S3 bucket created. So in this Redshift, there are some parameters like CPU utilization. For example, we want to monitor the CPU utilization. We create an alarm based on that. So we just click on that and go to the next. So we just give the name, what is the description. If we just give the parameters like if the CPU utilization is more than 50% or more than whatever the parameter is taking. So here it is taking like 0.5, 0.75 and 1, which is 100%, 75%, 50%. So it is basically the same. If we give like 0.5, then what it is assuming is if the CPU utilization is greater than or equal to 50%, we'll get an alarm, like say whatever the alarm we choose, and we can choose that we'll get a notify me, will give the email to which will be sent directly to your email. So in that case, like that, when we are creating a Redshift, we can choose to create an alarm or no. So if we hit continue, it will show us whatever we created, so we can review all this and launch a cluster. So I already have a cluster launched, so if I launch another cluster, there will be billing cycle uh, pulled up. So I don't want to create a new one. I'll be using this one. So what I created is, I created a cluster, a single node cluster, which is DC1 large with the default VPC and all the other things are default. So when we created a cluster, this will be the window it will be showing. So in the configuration, we'll be getting all the details about the cluster, and in the status, it will show us if the cluster is available or not, it is healthy or not, if there is a maintenance required or something. So in the performance tab, it will give us how many queries are running and what are the CPU utilization. See, you can see the CPU utilization of the cluster is about 60%. So what are the network receive throughput? So what is the network transmission and receiving, and what are the read and outputs, and so how many database connections we are having, and what is the healthy status? Like my cluster is always being healthy, it doesn't go to unhealthy. So if there is a cluster which is going unhealthy, we can see it in the performance tab. So these are all the performance parameters we are getting in this performance tab. And the next one will be the queries. In this tab, we will be seeing like what are the queries we are running in the last 24 hours or last hour. So when I'm running a query in my SQL client, this will show up. So what I did in this SQL is I'm fetching the So these are all done by by the admin. So what I did in this one is I ran a SQL query. So it took 7.35 seconds to complete the query, and it has an identifier number. So in this way, we can monitor what are the queries, and we can, if there is a query running, we don't want a query running, we can simply terminate the query, select that, and terminate the query. And the next one is the loads. So in this loads tab, it will show you like whatever the loading is happened, whatever the data loading is happened. Like this, I loaded a table, I loaded data into the supplier table on December 1st. It took 7.35 seconds, which I showed you in the queries table, the same query. So it is monitoring the query and it is monitoring the load at the same time. So it is, the next one is like the same thing. I loaded the part table with the data on number 22nd. It took 7.382 seconds, like that. So this is another, like if you happen to delete a table from the database, and for example you committed the changes. So if here you will be showing whatever the table you deleted and which is the database and what are the schema, and we can restore the data table into the database from here. So these are all the tabs we get from when we create a cluster, and what is the usefulness of the tab. So the next one, what we did is we created a cluster in the Redshift. So next step is we have to connect to the cluster. So in this left hand side, you have a connect client. So in this connect, if you click into the connect client, it will show you some options. So in this client tool, the first step it is telling us to install a client tool. So we have a SQL workbench to connect, or we can connect to other ETL tools, third-party tools. So it is giving the partner tools. There is a list of partner tools which we can connect to Redshift and get the data into the Redshift. So for this demo, I'm going to connect the SQL workbench. So this is the SQL workbench. We can download it. It's a freeware software. We can download it. So these are the parameters we need to connect. So this is the driver, URL, and username and password. the username and password are the same username and passwords when we use them to create the cluster. So this is the URL. So the SQL Workbench will use JDBC to connect to the database. So we just have to choose whatever the driver to the JDBC. So the newest one is 4.2. I'm selecting it, and we have to download the jar file. So if you want to download the jar file, it will be there. So we have to download the jar file, and in the manage driver section, we have to add the location where we downloaded the jar file and click OK. So by doing this, in the driver section, it will be populated. So to get this URL, we have to go here and select whatever the clusters. If I have only one cluster, it is showing me one. If you have more than one, it will be showing more than one. If you choose it, it will give us the JDBC URL to connect to that. So we just have to copy and paste it here and use the username and password and click OK. So now it is connecting to database and it is connected. So now we are connected to the database using a SQL client. So what we did is we created a cluster in the Amazon and we connected the SQL client to that cluster. The next step would be loading the data into the Redshift. So the best way to load the data into Redshift, as I told you, is to upload the data files into the S3 bucket and get the data using a copy command into the Redshift. So first we have to go into services and type S3. So this will come up and go into the S3. So here S3 is a simple object storage. So we just have to create a bucket. So we just have to create a bucket like AST demo maybe. So we just have to select a region. So we have to be careful when selecting the region, because the Redshift I created is in the North Virginia region, which is the US standard for Amazon. So we have to choose the same region. If we choose it, we can choose other regions too, but if we choose a different region, the bandwidth will be different and the data loading time will be high. If both Redshift and the S3 bucket is in the same region, then the bandwidth will be the same, and it is like loading the data into the server from the same server. So we just have to go and create it. So it's now created. So we can upload all the data files into it. So I already created a demo. So in this I created a folder, and this I uploaded some CSV files into the S3 bucket so that I can load the data from this CSV files. So how to upload the data? So we can just have to upload it. So to upload the files, so each file can only be up to 5 terabytes. So we can upload a file up to 5 terabytes, but there is no limitation. So we can upload many files if you want, but there is only limitation of single file size, which is 5 terabytes. So we just have to add files into this. You can choose whatever the files. So it is an object storage. So you can choose PDF or even if your images or everything, we can store it there. So we just have to choose it and start upload. It will upload and the files will be showing up like this. So now we created an S3 bucket and we uploaded the data into the S3. So now what should we do is we have to get this S3 bucket into the Redshift. So now the question is, S3 bucket is another service and Redshift will be in another service. So how do we know the same user is accessing the both? So because this is another service and that is another service, there should be a way to use some credentials and used to authenticate, like the same user is getting the data from the S3 bucket. So if the S3 bucket cannot be open, like anybody can get it out of it. So for this purpose, we have to create an user which have the permissions to get the data from the S3 and load the data into Redshift. So we have to have a user which have permissions, who has permissions for both Redshift and then S3. So for this purpose, we have to go into another AWS service, which is Identity Access Management, IAM. So in this Identity Access Management, you can create users, you can create roles, you can create groups and assign users to the groups. It's basically an user administration service. So we go into the users, we add a user. So we just add a user. Like for maybe SG demo. For users, what is the access type? So programmatic access, like for all the command line tools and all the connections, we have to give the programmatic access. And if you want to have the console, the same console which I am seeing to different user, I want to enable this option too. So if we enable this option, it will ask you to set a password so that he or she can sign in into the console. So it can be an auto-generated password, or it can be a custom password. So we can use a custom password, and we can also set, if the user is logging for the first time, he or she can create a new password. So we gave the username and password, and next we have to assign some permissions. So one good thing about the Amazon is it already have some policies we can use, or we can create a new user. So it can be either customized, or we can use their policies. So I'm using the policies. So we can create a group and assign some policies, and you can attach the user to the group in the first step. Or without any group, we can give some policies, like for example, we are giving the Redshift policy and an S3. So there, here it is giving RDBMS, Amazon Redshift S3 role. So it provides access to manage S3 settings for the Redshift endpoints for DMS. So like this, we have some permissions or policies to assign. So we'll be giving, like, if we want to give a full access, we can choose this, and it will show what are the permissions it is giving in this tab. If we click the down arrow, it will show what is the action, like what are the permissions that user may have if we give this permission. So we have Redshift, and also we have to give the S3 full access. So in this way, it has the user AST demo has programmatic access and console access with a custom password and two policies. Like we have the Redshift policy and an S3 policy. So if we create a user like this, it will be created. So this is the user, and we have the access key and a secret access key. So for everything, for whatever we are doing in the Amazon, we have to have an access key and a secret access key. So in this way, we'll get an access key and a secret access key for a user. So we just have to copy the both and use it later. So now what we did is, up to now, we created a cluster, we created an S3 bucket, we created a user which can access both Redshift and an S3. Now we have to load data into Redshift. So going to the SQL client, and as I told you, using a copy command, which is given especially by the Amazon, we can do we can load the data into the Redshift. So which is easy actually. So this is the files I uploaded into the S3 bucket. So I just give copy into whatever the table name it is, part table. I'm loading the data into the part table from what is the data source, which is an S3 bucket. So S3:/ what is the bucket name, which is ASTDB, and what is the folder name, which is data load, and what are the file name, so which is part CSV table 000. So this is the from, and what are the credentials? As I showed you, we have to give the access key and we have to give the secret key. So by doing this, we will be loading data into S3 bucket. So the next what's next is we don't have to create so this is let's consider another scenario. Like I have an S3 bucket and there is one more colleague who wants to load the data into the AWS service. So what he or she can do is she can get the credentials from me and she can upload the same data into a different Redshift cluster. See, the scenario is I have a Redshift cluster on my own, I have an S3 bucket, and my colleague has a different Redshift cluster. So he or she wants to upload the same data into the Redshift. So he or she they doesn't need to create a new S3 bucket and upload the same data over there. I can give the same credentials, or I can create a new user. So from that user, he or she can get a new access key or a security key. So they don't have to create a S3 bucket to do the data. So which is I am going to show you. For example, I have some tables loaded already into the Redshift. So I'm going to delete data from the supplier table. So here is these many rows are deleted from the supplier table. So I'm going to load the data into the supplier not from my S3 bucket, from another S3 bucket which is owned by AWS. So Amazon has a sample bucket in a different region. It's a West 2, which belongs to Ohio, but my Redshift is in North Virginia. So you can see I'm loading, I can load data from a different region too. So this is the bucket name, and this is the folder name, and this is the whatever the file we are using to load the data into supplier. So these are all the credentials from the Amazon, which Amazon gave us, and this is the format of the supplier file, the gzip, and as it is in a different region, we have to add this line to our copy command. So it basically for every insert statement, it tells the Redshift it is in different regions, so that the S3 bucket, it has to go to different region and get the data from it. So if I am going to run this, it will insert the data. So it is executing the command. So you can also see it in the Redshift cluster, as I told you. So I ran a query, right? So I can go into the query and see it is running a query. It ran 6 seconds, and it is December 2nd, 10:55. It ran for 6 seconds and it is completed. Now we can see here it is completed, and it inserted this many records into the table. So this is how we get the data into the Redshift in a very efficient and a fast manner. So we have Redshift, we have created a Redshift, we have created a S3, and we have created a user which has access to Redshift and S3, and we loaded the data into the Redshift from an S3 bucket. So next part was connecting the Redshift into the Tableau I'm making a sample report using the sample data which I loaded into the Redshift. So we just have to open a Tableau client, desktop client, which we'll be getting for a 15 days trial. This is a Tableau public. So in the server, the first thing we have to do is importing the data. So there are only 3 stages: import, analyze, publish. So in the stage of importing, in the server section, we can choose, there are so many data sources we can choose from. So we just have to search Amazon Redshift, which will be the Amazon Redshift. So this URL is the JDBC URL, which is coming from the configuration section. This is the JDBC URL, or you can get the URL from here. So this is the JDBC URL. We just have to copy this part from the here to here and paste in the Tableau. And we have to give the HTTP, which is the database name, and the port, which we gave at the time of creation. And we have to give the password, master username and password, or you can create a new user to for the Redshift and give the username and password here. So we just have to sign in. And this is the part where we have to wait patiently, because what I loaded is a very big tables. For example, this line order, it has so many records. I'll show you. Let's count how many records are there in the line order table. So these many records are there in the line order table. To tell you how much time it took is, it took for me like 15 minutes to load this. So relatively, it's very fast to load data from the S3 into this Redshift. So I've selected the schema, and these are all the tables that are in the schema. So I loaded customer, date, line order, part, and supplier tables. These are the sample data from the Amazon. So these are all very big, so they might take some time to populate the analysis, so you have to be patient. So I just have to, so what we are doing next is we are choosing whatever the tables we want to make the report out of. So I'm choosing a customer and a line order table. So what it is doing is, it is asking me which tables I'm going to join. So I'm ordering a customer key to the customer key. So the join is complete. So if I update it, so there is data. So my join is working. So we can see that by joining different columns, we can update it and we can see whatever the data is pulling up. Now the data source is ready. So what we did is we just dragged whatever the tables we want and joined the tables in our orderly fashion. The next step is we create an analysis. So go into the sheet, and so we have all the dimensions, all the facts listed out here. So we just, what I'm going to build a report out of is, I want to build a report on revenue per region. So this is the region dimension. So I just have to double click it. I swear I double clicked. Yep. I just have to double click it. So the Tableau automatically pulls up the data, and it automatically chooses whether it is a row column or a row data or a column data, and it puts over there. As I told you, there is so much data in those tables, it will take some time. because I'm joining the customer table into the line order, so the data will be more bigger. So that's why it is taking time. Probably like a minute or two that should show up. Oh, finally the region dimension is loaded up. So the next thing is we want to calculate the sum of the revenue per region. So I'm not doing anything, I'm just picking the revenue column. When I'm dragging it, it automatically, oh, somehow what? So like this, I'm dragging it, it automatically calculating the sum. So again, we should be patient. Again, it will also take like a minute or two. Finally, it showed up. It almost took like for executing the SQL, it took like 2 minutes and 2 minutes. So this is the graph that Tableau automatically populated. So we can now do our customizations. Like first of all, I don't want to see everything in the same color. So I want the regions to be differentiated in different colors. So I'm pulling the regions into the color dimension. So what happened is it gave a color to a single one. So I say this graph is not graphically good. So I want to choose a different graph. So I go into show me, and what Tableau does is in here, it will give us what are the available graphs based on our data joining. So it has this one shows up the only the whatever the data in it, and this doesn't have any graphical. So this will give us the pie chart of what is going on, and this will give us a good graphical view. So from here we can see this one Asia have this much revenue, America has this much revenue. So by looking into this, we have all the regions with whatever the revenues respectively. So the another customization we can do is we have to filter out. What if we have to compare only two regions? So we again pull the region into the filters tab. So it will ask to choose what are the filters you need, and we have to have all, and click OK. And the filter is added, but it is not showing up in our window. So we just have to go and tell it to show the filter here. So now it is showing all, so we don't need all, we just need Africa. So we just want to know what is the revenue from Africa. We can know that. We just need to know, compare Africa and America. We can know that. As it is a sample data, everything looks the same. So we just need to compare 3, we can do that. So this is one of the analysis we can make like this, and the next step is getting the analysis into a dashboard. So for example, if we have 2 or more analysis we want to show up in a single window, we create a new dashboard. See, there is a button here to create a dashboard. So in here it will show up what are the sheets we have, and drag it and drop it. So it will show up this analysis with the respective filters and identifiers. So this is how we create a dashboard, and we can rename the dashboard like regions and their revenue. We can bold it, we can even color it like this. So now if we click this, it is presentable. So what up to now we did is we created a cluster, we created an S3 bucket, we created a user to connect for both S3 bucket and the Redshift, and loaded some data into the Redshift and connected Tableau and made a simple dashboard out of it. So this is how we create it, and this is all I have for my session today. And we can go ahead and have some question and answers. And thank you so much for listening to me. And if you have any question and answers, you can ask.
So you've used both the bits and the Tableau.
Mm-hmm.
Do you want to comment on the similarities and differences?
Yeah. Dickinson Joseph asked me a question like, can we get the similarities of BIX and Tableau? So the main difference would be is BIX is more powerful than Tableau. We have in the BIX, as you know, we can do our modeling, data modeling and stuff, and we can do the customizations of data, and we can do the aggregations itself. But in the Tableau, it's like doing on the fly. So as I showed you, I didn't do the sum as aggregation by myself. Tableau took it by itself, so there are some automatically aggregations that they're doing it. And comparing to our data visualizer and Tableau, I feel that both are similar in every kind. We can do the same things in everything, and I think that will answer your question. And the future scope of this session would be like comparing the same data, getting the same data in the Redshift and in our database, in the Oracle database as service, and creating the same report in the Tableau and see which one will be faster. That will be the future scope of this session. Yeah. So if any of the attendees have any questions, you can ask in the chat box, I think so. Or if you want me to unmute you, I can do that. Okay, since nobody has some questions, this will be the end of the session. And if anybody has any questions, please email it to me. Thank you so much for listening to me patiently for like more than an hour. Thank you so much.